Wish, you gotta start putting some ads, right? Alright, so, solids of revolution using the washer method. So, we're gonna have two curves. So this is the first one. I don't know the equation of it or anything, but it's just some curve. We're gonna revolve it around this axis, which we're gonna say is the y-axis. Okay, so if I'm revolving around the y-axis, that's gonna be a what kind of a problem? A dy problem, right? I'm gonna need to make my equations x equals. I need to use right minus left for any radius that I'm trying to find. And I need to use y values as my limits. Cool? Alright, so let's see. I don't know what I'm gonna create today. Let's see.
That was loud.
So,
It's a long.
this is the space that is going to be, we're going to say, bounded by the two curves. And this is the space that we're going to revolve around the y-axis. So as I revolve that, there's going to be a space in the middle that is not what? That is not filled in, with this, right? Do you understand?
Yeah.
Okay, so I'm going to try to do that. This will be the space that is not filled in, right?
It's like breaking news. Wow.
Should it be a beam?
You mean interstellar?
That's the space that is not filled in, right? Because this is going around that, right?
Oh my
Can you visualize it?
Yes.
Sort of? Now I'm gonna try to do this on the other side. It's gonna be hard.
Cover. Remember that video with the one the guy goes to the basement?
Let's try and just see. Comes around like this,
And then like
goes in,
puts his
right?
dollar trying to take it out. So he
Yeah.
gets something.
Something like that?
Oh, I didn't see his screen.
I don't know.
They reminded me of that.
So now I'm not gonna shade it in, but I'm gonna draw the bigger circles, right?
Wait, that's supposed to be the same size.
Oh.
He looks like Squidward's legs. Like when he eats all those Krabby Patties.
Oh
Yes.
Cool? I don't know what that is supposed to be, but yeah.
Oh yeah.
Like when you went
A
handsome.
hole in the middle.
Oh, yeah.
You could think of this as those cups. I don't know if you've ever bought one of those cups that has like something in the middle and that you get to freeze it and it becomes like ice in there, right? And you put your liquid around it so it keeps it cold. So that's kind of an idea of where this would be used, right? You're trying to create a cup that has that hole in the middle. Yeah? Cool? No, I'm not saying this is a cup, but this came out in the other class. They were like, oh, it's a bead. And I'm like, yeah, it looks like a bead.
A bead.
A bead.
Yeah, like-
Oh yeah, like a bead.
Yeah, like a bead. Kind of for a bracelet.
Or a
Okay?
necklace.
So, do you see the big cylinders?
No.
There's a big cylinder on the outside, right? And then there's a smaller cylinder on the inside. So to find the volume of just that that bounded space, right? We have to get the whole thing, like if it was all complete, one big cylinder, minus the other one inside. Yeah? Alright, so, let's write that down. There will be 2 sets of discs created. Right? There's an outer disk and then there's an inner disk. Yeah? So in order to find the volume of that bounded space revolved around a particular axis, we have to subtract the volume of those 2 disks, right? Yes? We have to find
He's like,
the volume of the outer disk and subtract the volume of the inner disk. Yes? And we have to do that infinitely many times as those disks get infinitely thick. And then that'll give us the exact volume of that shape. Okay? Do we know how to find the volume of disks? Yes, right? So technically it would be like, what would be the two things that we would need for each disk? We need the radius, right? So one of them is going to have a big radius and one of them is going to have a small radius, right? Okay, so do you see that down here happening?
Yes, sir.
Okay, so there's going to be two radius. There'll be two different
It's interconnected.
radii. I don't know, does that have two eyes or just one?
You
Two
said,
eyes?
what did you say?
So there'll be two different radii, right? One for each disc.
Interstellar.
Now, how you find that radius will be the same way we found it for the other ones. Top minus bottom or right minus left, depending on what we're revolving around, okay? For this one, it's a little bit tricky, okay? So, you notice that the smaller radius is going to be always from where we're revolving, from that axis of revolution to the closest curve to it. You see that? The bigger radius is going to be from the axis of revolution to the curve that is what? Farthest away from it. Okay, this space right here was the space that was bounded, the bounded area. And that's the space being revolved. So if we come up here to this picture,
Oh, okay.
okay, the inner radius, the little one, will be from here to where? To right there, that's little r. That's the small radius for the small disks. To get the other one, it's going to be from that same axis of revolution all the way to the outer curve. That's going to be my big radius. You see it? Pretty cool? Right? So we're treating those big disks as being complete minus the little disks. That way we can just get that other space. It's awesome, right? So if we wanted to find it, we would say the volume pi times the integral from A to B. Which one would be the outer disk? The big R or the little r? So that was big R squared dx or dy. Right, so this is the volume of the outer disk, and we need to subtract pi times the integral from A to B, the volume of the inner disk, little r squared dx or dy. Now could we put that whole thing together into just one integral?
Yeah.
Because they both have pi and they're both going from A to B? Yes, and when you do that, that becomes the formula for the volume of a solid of revolution using the washer, which is done. You see it? Yes? The part that kids always forget is to square the radiuses after they find them. Okay, they just get them and then they subtract them. They don't square each one before they subtract. Okay, so be careful, don't make those mistakes. Pretty cool? Again, to find big R and to find little r, it depends on the axis of revolution. Whether you use top minus bottom or right minus left. Okay, if it's something that looks like the x-axis, dx, something that looks like the y-axis, dy. Okay, and it's always going to be the distance between the axis and the outer boundary for r, the axis and the inner boundary for little r. Okay, so I draw these little lines. Okay, go to the axis, go to the one closest to it, go to the one furthest away from it, and then you can label big R, little r. And then you find it. Okay, here we would do right minus left, so it would be whatever this equation is minus this axis, whatever it is. If this was the y-axis, it would be 0. For this one, it would be whatever this equation is minus 0. So you're subtracting the two things where my dots are. Understand? Yeah? Okay, let's do some examples. Hopefully it'll make sense. Hopefully but it should be easy. All it is a formula that you're applying. The hard part is to find the things that go in the formula. Alright, so, write down the formula again. We just did it. See if you can recall it. I times the integral,
A to B,
a to b,
big R squared,
big R squared,
Bigger.
little r squared, dx or? How we find the big R and the little r will depend on whether we're revolving around something that's like the x or something like the y. Cool? So let's look at this first example. Find the volume of the solid created by revolving the region enclosed by x squared plus 1 and y equals 2 about the x-axis. So we're revolving around the x-axis, so we know this is a dx problem. We know we're going to have to do top minus bottom to be able to find that big R and that little r. Okay? Let's draw a little sketch here.
Oh.
Everyone's excited.
Wait.
X squared plus 1 looks like that, right? Y equals 2. It's right here. Looks like that.
You like
And we're revolving around the x-axis. So can you see that if I get this space right here, and I revolve it around the axis, is there going to be an empty space in between that's not filled in? Yes, right? It's going to be this right here. Cool? Now if we're doing dx, we're going to need x values as our limits. So what do you think those x values would be? From where to where? What would we have to find?
when they intersect y equals 2.
We have to find out where they intersect, right? So how can I figure that out? Set them equal to each other? Minus 1, so x squared equals 1, square root, x equals plus or minus 1. So it is from negative 1 to 1. Hi.
Can I get something from one with this?
Sure.
Oh,
Interesting. All right, are we good? All right. So,
They're recording.
find R and little r. There's a couple of things you got to remember, okay? So to find R, okay, you're going to start at the axis of revolution and go to the, oops, I forgot to the curve furthest away. Okay. To find little r, again, you start at the axis. And go to the curve closest to it. Okay? So for this one, if I want to calculate my big R, I'm going to go to my axis of revolution, and I'm going to go to the curve furthest away. That's going to be my big R.
Okay.
To find the little r, we're going to go to the axis, and we're going to go to the one closest to it. So that's little. Now to figure out what they actually are, I have to follow this formula, top minus bottom. This will be the top, this will be the bottom. This will be the top, this will be the bottom. Do you understand? Okay. On the side, we're going to figure out those before we plug them. So for big R, what's the top curve? What's it touching up here? 2 minus, what's the bottom curve? 0. That ends up just being 2. That's how big that is, right? Does that make sense? If I go from here to here, should it just be 2? Yeah, right? It's a flat line. One big cylinder, right? Little r, okay, it's going to be this equation, which is x squared plus 1 minus this equation, which is 0. That just becomes x squared plus 1. Now, it's not always going to be 0, right? Because it won't always be an axis. So we're ready. The volume is going to equal to pi times the integral from where to where?
-1 to positive.
-1 to +1. What's big R?
2.
2, don't forget to square it, minus little r, x squared plus 1.
Square.
Now you can say your line, Eddie. Just square it. Dear.
Nobody else gets it.
You don't get it?
Good.
It's a first semester thing. Cool? And from this point, I'll let you type it in your calculator and tell me the value. I'm not gonna make you suffer and do it by hand. Do this on a regular calculator page.
If
If they ask it, yes. If not, if they don't ask it, it'll be something simple enough for you to be able to do it by hand. The one on the mock exam, all it was just a setup. Okay, but that one was a little tricky. That one had a combination of discs and washers in. You have to be careful. So we'll look at that one after we do the notes. What do we end up with for the decimal value? 13 point times pi, remember times pi. 13.404? Yeah, somebody just took off, typed the integral, forgot the pi in the front. Right? Easy?